Hi, and welcome back to another episode of Rachel Teaches Math. Today I'm going to be covering solving quadratics using the square root method. Now, square root method is really good when you already have your quadratic in vertex form, which is that a times x minus h squared plus k. Okay? Now, of course, we've done so many videos and so much practice going from standard form to vertex. Because of the time that it takes and the focus for today, I'm not going to show an example of how to go from standard form to vertex. Instead, I'm going to do two examples where the quadratic is already in vertex form. So after we do a few different methods for solving quadratics, you're going to see when it's best to use one method versus the other. Now, of course, if you already have your function in vertex form, I'm going to highly recommend that you use square root method. It's going to be the fastest, I promise. Now, just to recap, what does it mean to solve a quadratic? Well, that's essentially you're trying to figure out where it crosses, where your quadratic crosses the x-axis. Now, that doesn't always happen. You're not always going to have a scenario where it crosses the x-axis. So I'm going to show you also an example using square root method where that would not happen. And you're going to know very quickly that it's not going to cross. So again, when you hear about solving a quadratic, you might hear that you're looking for the solutions, the x-intercepts, or the zeros. Also, another one that I hear less frequently, but I still do hear it, is the roots. So you could say the roots of one problem would be like x equals q and x equals p. But of course, those would be numbers instead of q and p. So let's get into one where I know that it's going to work and it's going to work out nicely. I created a problem where I know I'm going to have a nice whole number. It doesn't always happen. You can have decimals, that's fine. But we have -2 times x minus 5 squared plus 32. The first thing I'm going to do is try to isolate my binomial. Your goal is to get this piece, this x minus 5 squared, by itself on one side. So I'm going to go ahead and subtract 32 from both sides of my equation. When I do that, now I'm left with -2 times x minus 5 squared equals -32. Okay. I'm going to divide both sides by -2. If I divide this side by -2, these cancel out to be 1. Divide the right side by -2. I'm not even sure if that's the right side. Yeah, the right side to be -2. And that -32 divided by -2 is 16. So now I just have x minus 5 squared equals 16. You are almost done. Now I'm going to have to erase this and start fresh, and we'll just clear the screen so I have enough space to finish the job. All right, so I have x minus 5 squared equals 16. Give me one sec. Okay. Hopefully I remember the problem. X minus 5 squared equals 16, because in my previous video I read the problem wrong and still solved it wrong. Anyway, think about inverses. We've been using inverses the whole time solving it. It said -32, or it said plus 32, so I added 32. It said times -2, I divided by -2. Now it says x minus 5 squared. The inverse of squaring is taking the square root of both sides. Okay. Square root and squared are complete inverses. They cancel out. I'm just left with x minus 5 equals. Now, the square root of 16 has two solutions. You have +4 and -4. So I'm going to say this equals plus or minus 4. And then I have to add 5 to both sides, because I'm not solving for x minus 5, I'm solving for x. I want to know where the intercepts. So my solutions are x equals positive or -4 plus 5. Now, of course, I can break that up. X equals 4 plus 5, so x equals 9. And then x equals negative 4 plus 5. Negative 4 plus 5 is 1. So my other x-intercept is 1. So in this example, my x-intercepts are 9 and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, I got lucky. So that's going to cross here and here. And then in some way, your quadratic is going to open up because this was still positive. Wait, actually the original was negative. So it was a negative 2. It's still going to cross. Let me just redo that. It's still going to cross at 1 and 9, but this one's going to open down because it was negative 2. Un momento, por favor, for those of us who habla de español. 2, 3, 4, 5, 7, 9. 6, 9. Okay, so it's going to cross at 1 and 9. My vertex will be between them, and it's going to open down. You don't have much space. Really, really ugly. Okay. All right, let's try another one. And like I said, I'm going to finish this with one that doesn't work out. Okay. All right, so my next example is 3 times x minus 6 squared minus 48. Just like the last one, we're going to add 48 to both sides. And I always tell my students, if you don't need to show me that step, if you can do it in your head, go ahead, do that. You've been solving equations for a long time. So I know if I add 48 from negative 48, they're going to cancel out. And then on the right side, I'll just have 48. So I'm going to actually skip that step, also to save space. And that means I have 48 on the right, and I'm left with 3 times x minus 6 squared. Divide both sides by 3. If I do that, I know the 3's are going to cancel out. 48 divided by 3 is 16. Okay, so I have x minus 6 squared equals 16. Inverse of squaring, what will undo that is to take the square root. Get a little bit. All right, so we'll take the square root of both sides. That I'm going to show because it's kind of a new step for us. And I have x minus 6 equals, remember it's positive or negative 4. Add 6 to both sides, plus 6. These cancel. And I have x equals positive or negative 4 plus 6. Now, we can always break that down. X equals positive 4 plus 6 is 10. So x can equal 10. X equals negative 4 plus 6. Negative 4 plus 6 is 2. X equals 2. Those are the 2 places where I cross the x-axis. For this one, I'm not going to do a sketch because I've been doing them. And the purpose is just to know that your solutions are x equals 10. It's going to cross the x-axis at 10 and cross the x-axis at 2. Okay, let's look at one that doesn't work and kind of talk about why. Let's see. What if I have 3 times x minus 5, squared, plus 48? Well, my first step is going to be to divide or to subtract 48 on both sides. Minus 48 minus 48. Okay. This cancels out. I'm left with 3 times x minus 5 squared equals negative 48. Great. Divide both sides by 3. When I do that, I have x minus 5 squared equals negative 16. Cool. Let's take the square root. Here, x minus 5 squared, the square root of that is just x minus 5. Here, the square root of negative 16. Square root means you're looking for 2 numbers, they have to be the same number, multiplied, that give you this number. So can you think of a number multiplied by itself that would equal negative 16? No, it's not possible. Now later on, and I do plan on teaching this to my students in class, we're gonna show that this is actually an imaginary number and we can use I to represent it. So at least for Algebra 1 purposes, if you are asked to take the square root of a negative number, what that means is that your function does not cross the x-axis, okay? So maybe it's hovering up here and going up. It's never going to touch the x-axis. This has no real solutions, okay? Now there are complex solutions, but no real solutions. All you need to know in Algebra 1 is that it's not going to cross the x-axis. You have no zeros, no intercepts, no roots, whatever you want to call it, okay? All right, let's look at one more example. Now it's going to work out, but it's not going to be a nice number, okay? So I want to show you what the best way is to represent your answer when you don't have like plus or minus 4, or plus or minus 2, or plus or minus 12, like a perfect square root. All right, so let's say I have something like -4 times, just give me 1 second, x plus 2 squared minus what do I want to use? Minus 9, okay, equals 0. All right, we're going to follow the same steps. And any of this that you can do in your head, please go ahead and do that. Shoot. Let me change this. That's not going to, this is also going to be one that doesn't work. I'm going to make this positive 4. Okay, so I'm going to add 9 to both sides. Plus 9. So I have 9 over here, and then I have 4 times x plus 2 squared equals 9. Divide both sides by 4. Okay, so then I have x plus 2 squared equals 9/4. Well, 9/4, 9 divided by 2 is 4.5. So 9 divided by 4 is 2.25. Okay, so I have x plus 2, and I'm actually just going to leave it as 9/4 because they're both perfect squares, and there's a little trick you can use. Equals 9/4. Take the square root of both sides. Okay, if I take the square root of x plus 2, I get, or square root of x plus 2 squared is x plus 2. Square root of 9/4 is 3/2, plus or minus 3/2. Okay, so just to make some more space, I'm going to erase up here. I'm left with x plus 2 equals plus or minus 3/2. Okay, so you can write like this and then just say minus 2, minus 2. For most teachers, just writing your answer as x equals plus or minus 3/2, or you can say 1